This is the third in the short series of webinars on designing right end trials with farmers. And the key messages I hope from the previous two sessions were these. From the first week, we talked about objectives, and the reason these are so important because everything depends on the objectives. Every other part of the design should be a response to these exact objectives you have. Then in week 2, we talked about many of the elements of the design and some of the decisions you have to make in choosing those elements of the design, and the fact that you need to probably review and revise them. And the elements that I talked about were these ones: the treatments or options that you're comparing, the sites, the participants, the plots or experimental units, randomization, replicates, controlling variation, and management. And I tried to explain that for all of these, we're used to doing experiments, and we have typical ways of typical definitions, if you like, or examples of what those elements look like. So we know when we do field plot experiments, we know what the plots often look like. They're often small units of land, maybe 25 square meters or something like that. I then said, actually, there are principles involved in choosing those. We don't have to do what we've always done. What we have to do is make sure that we understand the principles and that what we're doing is aligned with the principles, it conforms with the principles. And then I tried to explain how the principles need amending or need adding to when we're particularly involving farmers in more stages of the research, and why the principles need adding or amending when we're thinking about large N trials. That means trials which are done at very many sites or involving a large number of participants. And so, if you like, the recommendation was that we move from doing what we always do, things which come in that column called typical, to thinking through carefully why we're doing things and making choices which are appropriate for the new sort of experimentation we're doing, where farmers are more closely involved and where we're trying to work with a lot of farmers. What we're trying to do this week is I'm really extending this table with one more row, talking about measurement and data collection. Right? And I'm going to try and use the same thing of, talking about what the real principles are and how those get modified when we're thinking about involving farmers and when we're thinking about large N trials. So the basic rules are very straightforward. There are 3 sorts of things we need to measure. The first ones are what I call primary responses. They're the quantities that you care most about, and they're set by objectives. So very often that is something like crop yield. If the objectives are about improving yield, it's clear that crop yield is a primary response. It's one of the most important things you have to measure. If the objective is about reducing pest damage, then clearly the primary response is level of pest damage. So you should be able to look at the objectives of your trial, identify the primary responses, and you need to be able to measure them. The next set of things we measure are those which we measure to try and help understand the primary response. So for example, if we're interested in crop yield, we sometimes measure things like plant height or head size so that we can get more understanding of what we mean when the yield is high. Is the yield high because the plant was high, or is the yield high because the head size is big? Right? We can understand something about crop yield if we measure something like plant height or head size. if we're thinking about, pest damage is the primary objective, you might want to measure the timing of the damage. When did it occur? Did it occur early in the season or late in the season? Maybe that will help you understand better how a treatment is working. Okay? So we've got two types of things to measure there. Those primary responses and those which we measure to try and give us more understanding of where those, why the primary responses are the way they are. And the rules or the principles we should use here are, I think these are the three main ones. Measure things that you can use and explain. Okay? Measure things which are demanded by the objectives. And don't measure them or avoid measuring them just because it's standard practice or because you think it might be interesting. In trials all over the world, there's lots of data collected which is never really analyzed and interpreted because somebody thought it might be interesting and it turns out it isn't interesting and it's just been a waste of time to collect it. Now, when you're doing your own researchers' trials, if you waste your time, that's up to you. But remember now we're talking about trials with farmers, and you're not just wasting your time, you're wasting farmers' time as well. And you're wasting the time of your extension officers and technicians and everything else. So you really need to make sure that the measurements you're making are things which really are useful and are needed, and not just things that, well, we always measure plant height, so we're going to measure plant height. You measure plant height if you know it will be useful and if you know how to use that information. But don't measure plant height just because breeders always measure plant height. And now the third set of measurements are those which we take to help explain variation. Now, every researcher that does on-farm trials will tell you that you always find a lot of variation in the effect of treatments on different farms. And some researchers will say that's why it's difficult to do on-farm research or why we shouldn't do on-farm research. My view is that when there's variation between farms, we need to understand or explain that variation. And to do that, we need some measurements. So I'm just going to elaborate this with a small example. This is some real data. There were 70 farmers growing beans with and without inoculation. And the objective was to find out if inoculation increases the bean yield and whether this depends on the soil type. And also the project was interested in gender. So they want to see whether men or women are different in the way that they're able to use this technology. Okay? So in this particular trial, it's clear that bean yield is the primary response. And the soil type and the gender are things that we're going to measure because we're going to try and see whether they explain any variation, and they're part of the objective. This is one way of analyzing this data. And I'm putting this up, I'm showing you this while we're talking about experimental design, because I think if you try and envisage the way you will analyze data while you're doing the planning, it really helps you to plan the trial well. So this is one way of that we could analyze this data. I've plotted along the x-axis, I've got the yield on the control plot, that's the farmer practice plot. And on the y-axis, the vertical axis, I've got the yield on the treated plot, the inoculated plot. So each dot is one farm, and there should be about 70 dots on that graph. And the line I've drawn is the one-to-one line, the line where they're equal. So if you see a dot on the line like that one, there's a farm where the control and the treated yields were exactly the same. If it's above the line, it says the treated gave a higher yield. And if it's below the line, it says the treated plot gave a lower yield than the control. So we can straight away see that there's a lot of, on most of the farms, the treatment had a positive effect. There are a few farms that did worse off with inoculation. There are quite a few farms, particularly these down at this low end, where actually the treatment didn't really have any effect at all. And when we start then putting in the factors, we can mark the gender. I've just put men and women here. So the men are the green and purple dots. You can say actually they do tend to be more above the line than the pink and blue dots, which are closer to the line. So it looks if maybe on average, men are getting a bigger treatment effect than women are. We don't know why, but that's the way it looks like. Okay. But I've also put something else on there. During this trial, the technicians were monitoring what was happening in the fields. They were going and visiting farmers' plots, and they were noticing that some of these plots were well weeded and some were not well weeded and had not really been looked after by the farmers. And they got the impression that the treatment effect was bigger where the plots had been well managed. And so during the season, they collected data on whether each plot was well managed or not. And that's this one that says good or poor. They just said, is the management good or was the management poor? And it was mainly to do with weeding. And what you see now, when we separate those men who were weeding well and the men who were weeding poorly, the green ones are the men who are weeding well, and they seem to generally get a bigger effect than where the weeding was poor. So the green ones tend to be further above the line than the purple ones. So the point is that we're finding that both gender and this, how good the management was, are factors that are helping explain or understand variation between these farms and these farmers. And those are really important. Those are really important findings. You know, we really need to know why. Why is it that men are able to get more response to inoculation than women? That seems a rather strange thing. The fact that the inoculation seems to work if you weed well and it doesn't work if you don't weed well is something that's really important to the project. So if we think about the data needed, the data sheet for that trial I've just shown you looks something like this. There's a row for each farmer. Okay, altogether there are 70 rows there. I've only put some of them there. The first few columns are the plot identification. It tells us which plot is which and where it is. These two columns here are the primary response. That is the yield, in this case for the control and the treated plots. Then we've got those things which we measure or record because we need them to meet the objectives: gender and the soil fertility class. Notice that the soil class here is just two classes. They're just classified as sand or clay, nothing more sophisticated than that. But there's this fourth column here, and this was the management, whether it's good or poor. And this was needed to test a hypothesis that was developed during the growing season. That was added. That wasn't in the initial plan. That was added because the field staff thought they saw variation between farms and thought that it might be due to whether the management was good or not. And so they collected the data, and then it can be used in the analysis to explain variation. Right? So if we're thinking about those things we're measuring to explain variation, they can be factors that you hypothesize might be important as you did the planning. Those are those context variables, the things that we talked about during week 1 of this series. We're saying, think about those context variables that might interact with what you're interested in. And then there's another group, which are factors that you hypothesize might be important as the season progresses. So things that you didn't anticipate, but you see when you're monitoring what's going on. If you see something like variation in plot management, and you think it might be important, but you don't record it for each farmer, there's no way that you can use it when you come to do the data analysis. Okay? So if you think it might be important, you've got to measure it so that you can then use it in data analysis. And to do that well, it means there has to be some monitoring going on. Somebody's got to be looking at some of these farms to see what's happening. And there's got to be some communication. Whoever's doing that looking has got to be then communicating with the researchers or whoever's leading the trial so that they can decide that we're going to modify the protocol and we're going to go on each farm and we're going to record whether the weeding was done well or not, or whether the quality of plot management is good or not. And so that's an example of something that's different when you're doing these large N trials than what we'd normally do with ordinary field trials. But they can be, in examples I know about, these things that you observe during the season and then collect data about can be the most important ones. So you shouldn't ignore that. Now, if we think about farmer involvement now, we're talking about measurements, then I think there are some additional principles we need to think about. The first one is measuring things that farmers care about. It's very interesting. If you look at farmers' adoption of new varieties, they don't just adopt the highest yielders. They care about all sorts of traits of those varieties. And so if you're going to do useful variety trials, then you must make sure that you are measuring things farmers care about, not just the things that researchers normally care about. So an example for that is taste. Taste of the cowpeas, taste of the sorghum, whatever it is they're testing. It's something you might want to test, to measure. Second thing is using farmers' concepts and categories in what you measure. So I've already talked about this in relation to soil. You know, if you're involving farmers and you're trying to produce results which are really useful to farmers, then describing the soil fertility in terms of nitrogen content is maybe less useful than describing soil fertility using language that farmers themselves use to describe soil fertility. The third thing is that many of the farmers' decisions are based on preferences. They don't choose necessarily the variety that produces the highest yield or has the lowest pest tolerance. They will have an idea, they will have a preference for varieties that they want to choose. These preferences are subjective, and sometimes we can understand where they come from and why they feel that way about varieties, and sometimes we can't. Sometimes preferences cannot be predicted from other traits. What that means is you should be measuring preferences for the options, not just measuring how well does it work on a farmer's plot. So it's questions like, which is your preferred variety? Or would you like to grow this one next season? And it's not just, doesn't just apply to varieties, it applies to anything. Your trial on ogre, or your trial on partial weeding, the same things, the same sort of questions would be relevant. And the fourth thing you might want to think about when farmers are involved in trials is whether farmers are going to be actually involved in measuring and recording data. I know that there are challenges with farmers measuring and recording things, particularly if you have farmers who are not literate. But there are also some very good reasons why having farmers involved in measuring and recording data is often a good idea. And if farmers are not able to do it themselves, then there might be farmers' representatives in villages who can do that, rather than thinking that data collection and recording always means a technician or someone from the project coming in to do that. And that also is relevant when we think about what it means to do large N trials. Essentially, if we're thinking about measurement and large N trials, the key thing is to remove bottlenecks. By bottlenecks, I mean those points in the whole research process which make it difficult to work with large numbers of farmers. So, for example, if we're recording pests and diseases, if you want to record pests and diseases on crops across large numbers of farmers, if technicians are doing that alone, they're probably only going to be able to go to the field once. And yet, understanding pests and diseases, you often need to be able to record things throughout the season. It matters when the pests occur, not just whether they occur. So if you've got just a few farmers, the technicians can go and visit them every 2 weeks to record the pests. But if you've got 1,000 farmers, the technicians are not going to visit them every 2 weeks. At most, they could do it once in the season. So if you had farmers recording the data, then you remove that bottleneck of technicians having to go frequently. A more common bottleneck is requirement for technicians to be in the field at harvest time to measure, for example, yield. Okay? And that's a problem because for two reasons. One is you don't know exactly which day any farmer wants to harvest. And it's often hard for the technicians to be in the field for when every farmer is harvesting. There's too many of them. They're all harvesting about the same time. The technicians can't be everywhere at the same time. So the way you avoid that is don't measure yield at harvest. Now that's surprising recommendation for many people. If crop yield is the most important response you have, why am I recommending not measuring yield at harvest? What I'm suggesting is that there are alternatives to the traditional way of doing it. And here are just a few of them. The standard way we measure crop yield is we go in an experiment is we harvest the plot and we weigh it and we maybe take samples for doing dry matter determination. And that needs to be done by a technician. And obviously it has some advantages. For example, it gives you a good estimate of yield in kilograms per hectare. But the disadvantages are a lot when you have large numbers of farmers, because it's a slow process and the technicians or field staff who are collecting the data have to be in the field right on harvest day. So here's the first alternative. Have farmers do the harvesting and measuring it in some sort of standard container. Now, farmers don't have weighing machines, but it's sometimes possible to provide some sort of standard container like bags. So farmers harvest it and they measure how many bags full they get. And if you then weigh a few of the bags, you can work out how many kilograms are in a bag, and so that you could still get an estimate of yield. But farmers are doing the measurement, and they're not weighing it; they're measuring in some sort of in a bag or some other kind of container. So there's some advantages in that. The disadvantages are that farmers will need some training, and there's possibility of bias. Here's another option. Rather than going at harvest day and measuring the yield exactly, you could perhaps go sometime before harvest and just do a prediction. And I've seen various ways in which people try and do a prediction. And sometimes it works, but sometimes it doesn't work very well. Another option is not to try and measure it directly at all, but just have farmers estimate it. And not even estimate it in terms of kilograms, but estimate it on a scale like it was poor, it's about the same as usual, it's much better than usual. And actually that has some strong advantages. An assessment of yield based on a scale like it was poor or not as good as I expected or something, or it was okay or it was much better than I expected. That's really based on farmers' perceptions. You're capturing not just the biological performance of the plant, but you're capturing what farmers feel about it as well. But of course, it is subjective, meaning that if somebody else went to take the measurement, they might come up with a different answer. And it's also possibly subject to bias. And I'll say more about bias in a minute. And then the last alternative here is farmers actually just ranking the alternatives, to saying of the ones they've compared, which one's best, which one's second best, which one's worst. And that's something which is very, very easy. It's a very, very easy thing to do. Farmers, as long as there aren't too many options, farmers find that very easy to do. But there are some disadvantages. The strongest one is actually a rather curious thing, that this only gives you the relative ordering of the options. And for example, C might be the best one there, but that doesn't tell us whether farmers think it's very good or just okay, or might even think it's bad. It might be, they might all be bad. It's just that C is the best out of all the bad ones. Now, and there are more possibilities as well. My point is that just because we're interested in yield and farmers are interested in yield doesn't mean that we have to every time go and measure yield in terms of kilograms per hectare by harvesting the plot and weighing it. There are always alternatives. And when you're working with farmers and when you're using large N approaches, then you need to think carefully about what these alternatives are. So, when more principles for measurement in large N trials. First one is the precision of measurement is not very important. So for example, if I say the yield on this plot was 600 kilograms or 631 kilograms, the difference doesn't matter. Small errors like it, rounding to the nearest 100 kilograms, that's fine, because when we have a large sample, those errors sort of balance out. When measuring diseases, people often try and assess, percent of the plants damaged or the percent of plants which are diseased. You can do something much simpler. You might have a scale which just says there was no disease. There was some disease, but it didn't seem to do much damage to the yield. There was some disease and it reduced the yield, or we got no yield at all because of the disease. That sort of scale of assessment, it's very easy to collect that data, and it's often good enough, it's precise enough. What we do need to be cautious about, though, is bias. And by bias, we mean a data collection method which consistently gives you too high or too low values. And the problem with that is, even when you have a large sample, the errors don't balance out. If farmers consistently tell you the disease was worse than it really was, then even if you've got 1,000 farmers in the trial, you're still going to think that the disease was worse than it really was. So we need to find ways of avoiding bias, and that often comes down to training. Third one, involve farmers in collecting data that makes sense to them. Don't expect farmers to be able to be interested or to do a good job of collecting data that they can't see the use for. If you're going to involve farmers in measurement, then the things they're measuring should be things that they understand and that they're interested in. And the last one here is devise scales that farmers can understand and use, including farmers' categories. And just, I put this example from a recent paper. The Jacob van Etten, who's been developing this, the biodiversity method of doing large N trials, showed this example of their data collection form. And it's extremely simple. They've tried to put in pictures of what they mean by these things. So yield, we see here's a big plant for high yield. Here's a small plant for low yield. Here's a big one with high market value, one with low market value. So some pictures to try and illustrate what they mean. And all you do, the farmers, remember, in their scheme, farmers compare 3 options, which they call A, B, and C, and you just have to say which is the best and which was the worst. Right? So extremely simple data collection, and using words and collected in a way that farmers can easily understand. So once you've decided what you're going to measure, then you have to actually be clear about the protocol for measuring it. And that's sometimes actually quite tricky to do. So here's an example. This was to do with measuring damage due to pests and diseases. And the instruction or the protocol said, inspect 10 plants per plot and record how many are damaged. That sounds quite straightforward, doesn't it? Okay, so I'm going to inspect 10 plants per plot and record how many out of 10 are damaged. But then it raises all sorts of questions. So which 10 are we talking about? If you're supposed to select 10 at random, how do you select 10 plants at random in a plot? What do you do if actually there's a rather poor plot and there are less than 10 plants in the plot? Well, if I select 10 plants and none of them have any damage, but then I can see that there are other plants in that plot which are damaged. What if I look at the plot and I can see one half of it looks really good and the other half of it looks really, really bad? What do I do? Am I still going to take 10 plants at random, or do I do something else? Now, so this simple example here could easily raise all these sorts of questions when somebody tries to apply it in the field. And your protocol for collecting data needs to answer these sorts of questions so that you don't have that questions like this could not arise during data collection. They need answering, resolving before the data collection starts. And that means that you need some sort of training and some sort of piloting, testing things out will be necessary. And that's what I wanted to talk about in the next and last session next week. And so that's it. So what I would suggest for the task for next week would be just specifying the measurements for your trials. What are you going to measure? And these will be measurements that we take on each plot on each farm. So just specify those and send them to us, and we can talk about those next week. And then the last one of these 4 sessions next week was going to be about implementing. Once we've got the design well organized, how do we implement? And that's going to include some of these things about training and piloting and getting your data system well organized before you start.